Okay guys, part 2 of our look at trapezoids. On the end of the last video I gave you a set of coordinates to look at, determine whether it's a trapezoid. We're going to look at the slopes of all 4 segments, see if 2 of them are parallel. Here's how your work should have worked out. For slope QR you should have 8 minus a negative 4 over 0 minus a negative 8. That simplifies to 12 over 8 or 3 halves. Our slope of RS simplifies. We get 8 minus 8 over 6 minus 0. So we have 0 over 6 equaling 0. Our slope of ST should have given us negative 10 minus 8 over negative 6 minus 6, which is negative 18 over negative 12. That's 3 halves. And TQ, negative 10 minus a negative 4 over negative 6 minus a negative 8. Should have given us negative 6 over 2 or a negative 3 halves. You should see right away that we do have 2 slopes that are the same. 2 segments with the same slope. Yes, this is a trapezoid. But now we want to determine if it's isosceles, and here's how we do that. If it's isosceles, the 2 other sides, RS and TQ, must be the legs. Okay, the non-parallel sides. We should be able to do the distance formula for RS and the distance formula for TQ. If it's an isosceles, those 2 distances are going to be the same. Pause the video, find those 2 distances, and when you're ready, hit play again. All right, let's look at our answer. RS, and I'm just going to kind of write the answer here. You would have found something like the square root of 36, which actually just equals 6. For TQ, you should have gotten the square root of 40. Okay? That does simplify to something like 6 point something. Okay? But obviously, square root of 36 is not equal to square root of 40. So we now know this is a trapezoid, but it is not isosceles. Okay? All right. Little bit of work there you have to go through to determine this, okay? Let's move on to the next example that is on your guided notes. And here's what I want to do. On this set, try this again. Find the 4 slopes. See if you have anything that is parallel. You should end up with one set that is. Then check the distances of the 2 that are not parallel. See if it's isosceles. Pause the video, work those problems out, and I'm just going to bring the answer up here after you've had a chance to work it out. All right, hopefully you had a chance to work through the second problem. And again, if you get a wrong answer on this and you're just stuck and you cannot figure it out, ask for help from your classmates, okay? For ABCD, you should have found that slope AB was 1/4 and slope CD was also 1/4. Those are our parallel sides. We have a trapezoid. So, if those 2 are your parallel side, your legs had to be BC and DA. You would have found the distance of BC is square root of 17 and DA is square root of 18. Close, but not close enough. This is a trapezoid, but not isosceles. All right, so we've got a couple examples of the coordinate geometry down. All right, let's move on to the last bit of trapezoids. There is something called a trapezoid midsegment. This is the bottom of your second page of the guided notes. So I'm going to draw one up here. And I'm going to draw one because this applies whether it's a trapezoid or an isosceles trapezoid. I'm going to draw one that doesn't look like an isosceles so you can still see this. All right, we have a set of parallel sides. Okay? Again, works regardless of whether it's isosceles or not. We're going to start a line here that is a bisector of this leg. Okay, it's going to cut it here and here. It's going to also bisect this other side. Okay? So it's going to make that side and that side the same. Well, if we have a mid-segment that does this, okay, it turns out that it has two unique properties. The first one is this line is also going to be parallel to the two bases. Okay? Interesting to know. It has one other property as far as its distance. Okay? It turns out that if we take the distance of this top base, add to it the distance of the bottom base, and divide by 2. Okay? Add them together, divide by 2, and average. That average is the distance of this mid-segment. Okay? All right. Those are the important things to add into your notes over to the right. Okay? So, let's look at the example on the next page once you had a chance to write that down. Okay? We are given a trapezoid, not necessarily isosceles, that looks like this. So we have F, G, J and K, H, L. At this point you should have most of this wrote. This should be pre-printed for you. Alright, and we know that this is distance x. We don't know what it is. We know this is 15, and this is 18.2. We want to find the value of x. In other words, we want to find the distance from F to G. Alright? Well, we can use this idea that this is an average of the two to find it. So here's how we do it. And I'm going to move to this side real quick. If we added 18.2 plus x and divided by 2, so 18.2 plus x divided by 2, that's going to equal what? That should equal 15. Okay? At this point, guys, this is Algebra 1. All right? We'll take both sides times 2. We're left with 18.2 plus x equals 30. And x equals, we just subtract 18.2 from both sides. That should leave us with 11.8 for the value of x. Okay? One example problem you'll get. Let's look at the last one. Okay? All right. We're given something that looks a little different here. Okay? And it's A, B, C, D, F, and G. And this is a trapezoid, A, B, C, D, has a mid-segment of FG. Okay? If this is where the mid-segment is, we can also say for sure that this and this line is parallel. And of course, the mid-segment will also be parallel to that one. The mid-segment is FG. We want to know these coordinates right here. X and Y. This is a coordinate problem. If we're given D, which is 1/4, and C, which is 20 and 0. Well, again, this G, if it's a mid-segment, it's going to cut this into 2. So what are we going to use for D to C to find G? The midpoint formula. So we add up our x's. 1 plus 20 divided by 2. That'll be our x value. 4 plus 0 divided by 2. That will be our y value. That should leave us with 1 plus 20, which is 21, divided by 2 is 10 1/2, or 10.5. 4 divided by 2 is 2. That is your coordinates for G. Okay, guys, we're stopping there. I know this was a couple of long videos and a lot of concepts to hit at one time, but I do want to get all the way through trapezoids today. Start on the homework, ask your fellow classmates for help, rewatch the video if you need to, or just the parts you need, and we'll see you when I get back.